Hello, class. Today we're going over the 9.7 factoring special products. So these are special types of factoring problems that have a pattern that you can see and use. So first we're going to start by working with two multiplication problems that'll kind of help you see how we could work backwards to factor. For the first one, we have 3x plus 2y times 3x minus 2y. Now, if we multiply this the long way, so using FOIL, 3x times 3x is 9x squared. 3x times negative 2y is negative 6xy. 2y times 3x is positive 6xy. And 2y times negative 2y is negative 4y squared. Now notice, in the middle, we have negative 6xy plus 6xy. So those cancel out, and it just leaves us with 9x squared minus 4y squared. So notice the middle terms cancel out, and we're left with the first times the first and the last times the last. For this problem, x plus 5 times x minus 5. X times x is x squared. X times negative 5 is negative 5x. 5 times x is positive 5x, and 5 times negative 5 is negative 25. Again, notice those middle terms cancel out, and we get x squared minus 25. Okay, so now if we were working backwards, if they gave us x squared minus 25, notice the factored problem is x plus 5 times x minus 5. So essentially the two sets of parentheses have the exact same thing except for the sign in the middle. Okay. So let's go ahead and apply this into some factoring problems. In this next section, we're going to factor completely. X squared minus 49. So notice both of these are perfect squares, meaning a number squared equals each term. So x is squared, and we could rewrite 49 as 7 squared. Okay. That's a good sign. Also, you can think of this as having a 0x in the middle. Since there's no x term, we're trying to get 0 in the middle. So when we factor, x squared is x times x, and I would use 7 times 7 for 49. If we make them opposite signs, notice we'll have a positive 7x and a negative 7x, which would make the 0 in the middle. Okay. So again, anytime it's difference of squares, meaning you could find the square root of each one, or you could rewrite it as squares, you will have two sets of parentheses with the square root of the first term in the first spot of each one, and the square root of the second term in the second spot of each one. So looking at number 4, 81 is a perfect square, and x squared is a perfect square. So x squared is going to be x times x in the first spot of each set of parentheses. 81 is 9 times 9, so I put 9 in the last spot, and they're going to be opposite signs in the middle in order to cancel out that middle term. For number 5, it's okay that there's a number attached to the x squared. We have 9x squared minus 25, because that 9 is a perfect square as well. So the difference is, instead of just having x times x, it'll be 3x times 3x, because the perfect 9 is the perfect square, 3 squared. Okay. And then for the 25, we'd use 5 and 5, and it'd be a plus and a minus. For number 6, 16x squared minus 4y squared. So there's two variables here, which a lot of times can throw students off, but both of them are squared, so it's okay, it'll work out, okay? Also notice that both of these have 4 in common. So we could factor a 4 out, which would give us 4x squared minus y squared. And now we can factor what's inside the parentheses. Square root of 4 is 2, so we'd use a 2 with the x, 2 with the x. And y squared is y times y. And they would have to be opposite signs. And that would be it. So notice if they have something in common, we do take that out first. All right, now we're going to look at a different type of special factor or special product. This is the perfect square trinomial. So first we'll work through multiplying, and then we'll look at it working backwards. So recall that when we have x plus 4 squared, when we have an addition problem squared, it means you're taking that addition problem and multiplying it by itself, okay? You cannot distribute the squared. You have to do x plus 4 times x plus 4. So when we multiply these together using FOIL, x times x is x squared, x times 4 is 4x, 4 times x is 4x, and 4 times 4 is 16. We would want to combine those middle terms to get x squared plus 8x plus 16. So notice the first and last term are both perfect squares. For number 8, 2x minus 5y squared, we need to take 2x minus 5y and multiply it by itself. Again, we're going to use FOIL. 2x times 2x is 4x squared. 2x times 5y. So it's 2 times negative 5, so it's a negative 10. And then we just put the x times y with the 10. For the next one, negative 5y times 2x, it's a negative 10 times the x and the y again. And then negative 5 times negative 5 here becomes a positive 25 with the y squared. We do want to combine these middle terms since they both have an x and a y. So it'd be 4x squared minus 20xy plus 25y squared. And notice again, first and last terms are perfect squares. 4 is a perfect square. 25 is a perfect square. If you struggle with perfect squares, I would suggest looking up a list of perfect squares and maybe some more information on Khan Academy about perfect squares. All right, so we're going to use this pattern where we have the perfect squares to work backwards. So ideally, what's going to happen in this next section of factoring is our final answer is going to be something like this. So a binomial squared, okay? So keeping that in mind, y squared minus 12y plus 36. Y squared is y times y. 36 is 6 times 6. So those were both perfect squares. Since this is a negative, we know we need to have negative signs, and they both must be negative since this is a positive. Negative 6 times negative 6 is a positive 36. Now, since these are the exact same thing, your final step is you want to write this as y minus 6 to the second power. For this next one, 2 sets of parentheses again. X squared is x times x. 121 is a perfect square. It's 11 times 11. All of these are positive, which means this will be positive as well. And you would want to write that as x plus 11 squared. For number 11, 4x squared plus 12x plus 9. 4 and x squared are perfect squares. 9 is also a perfect square. So for 4, square root of 4 is 2. Notice we've been using whatever the square root of these values is. So it's going to be 2x times 2x. For 9, it'd be 3 and 3. All positives in the original problem, so positives here, which means our final answer is 2x plus 3 to the second power because both of these are exactly the same. All right. So now for this last one. Notice 16, 64, and 64. All of these can be simplified. They're all divisible by the same numbers. We should be able to take a 16 out of all of them. So if I take 16 out, it's x squared minus 4x plus 4. Right? Because 16 times 4, you can even check over here if you want. Multiply them back in. it does equal 64. Okay, so that works out. Now that I took the 16 out, I have a smaller perfect square trinomial to work with. We just have the x squared and the 4 to worry about. X squared is x times x. 4 is 2 times 2. Since this middle term is negative, these need to be negative. Okay, because -2 plus -2 is -4, but -2 times -2 also gives us the positive 4 at the end. Okay. Our last step is we do want to combine these into a squared, so it'd be 16 times x minus 2 squared. And that's it for your notes today. Your homework is out of the book. It's 9.7. And it's problems 3 through 19 odd. And then you have to do 25 and 27 as well. If you have any questions, feel free to message me on Canvas or check in with me tomorrow. Have a good day, please.